Neuro. Today we talked about the second half of muscles and motor neurons and just our movement system. And we talked a lot about these things called upper motor neurons that are in 3 places, and they drive all of what happens in your spinal cord and the muscles at the level of that final common pathway that comes out of the spinal cord to talk directly to the muscle. And the motor cortex is this area right at the back of your frontal lobe. And it basically is a map on either side, and it's represented according to how many muscles you need to innervate. So if you have a lot of muscles in something like your hand or your fingers, if you're writing, then you would have a lot of motor cortex space devoted to your fingers, whereas maybe not so much to your back because you don't have a lot of fine motor control in your back. So you have a frontal lobe then where the very back of it does motor stuff. And then kind of going forward, the next area does like pre-planning of motor. And then the next one does kind of more like integration of other cognitive things and sensation and all coming together. And the very front part, your prefrontal cortex, is where we have our seat of kind of like personality. So this is where your decisions will be made. This is where you're going to integrate kind of attention and judgment and reasoning all together. And this is kind of what makes us who we are. And so the prefrontal cortex is going to be where this kind of stuff takes place. And then it'll send its decisions back. So it'll go to processing, and then it'll go to the motor cortex, and then you'll move. You'll have made a decision. And so the other 2 things that we talked about are an area called the cerebellum, which is here in the back. And the cerebellum is responsible for movement, but more like timing and automatic ideas like how to ride a bike or movement that you learn and you practice over a long period of time. And also like feedback in terms of like, where am I in space, and am I where I think I am? And if I'm making a motion like this, how do I at any given point know if I'm supposed to go up or down in order to have it land right on my nose? So the cerebellum is involved with this, and it sends input directly up to the brain, but it doesn't send it down to the muscles. So it kind of coordinates with the cortex so that the cortex can make good decisions. And then you have the basal ganglia, which is like a system of 3 or 4 big areas right in the core of your brain, right in the center. And they're called the caudate putamen and the globus pallidus and the substantia nigra. And what happens there is kind of a cool system where one of these guys, the globus pallidus, is always constitutively like on, and it's telling the thalamus, which is the relay system for the rest of the brain. It's saying, no, don't do it, don't do it, don't do it, don't do it, don't do it. Okay. And you have a situation where the thalamus is constantly being told to stop, don't make movement. Okay. But then because this is a chain of linked brain structures, you have somebody who's kind of upstream of the globus pallidus, and that's the caudate putamen, and also the substantia nigra, and they are able to send information in order to have the globus pallidus actually shut up for a second and let the thalamus do an action. So when the caudate putamen activates, then the thalamus will end up getting to talk. Basically, then the thalamus can say, hey, go to the cortex. It'll go up to the cortex, and then you will have a motor movement. So it's a kind of complicated system, but the brain likes to do this tricky thing where it has an inhibitor of an inhibitor. So if you inhibit a brain area that normally inhibits another brain area, then that's essentially like exciting that thing that comes downstream. So motor can be really complicated. It also is linked into a lot of learning and memory. So these learning, like how can I be plastic and think about how to change my way of movement and making these decisions. So this idea of dopamine and this being involved in this pathway has taught us a lot about the involvement of dopamine and reward systems and how that links into the ability to make good decisions. So those are the kind of three things that we talked about in terms of motor systems today. The basal ganglia also doesn't directly contact the motor system, but instead just can tell the thalamus to tell the cortex things to do. And again, we're just primarily making these motor decisions in our cortex and then sending them out for the rest of the lower motor neurons to respond to. And that is plenty of information about how our motor systems are set up. Muscles to lower motor neuron, then spinal cord, and then you've got the basal ganglia, the cerebellum, and then motor cortex on the top. Thank you. Join us every day in May for a new video.